Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problem number 6 of the 2019 AP Calculus AB free response questions. It focuses on derivatives, limits, and the Squeeze Theorem. Alrighty, let's take a look at question number 6, the A part. On question 6A, we're being assessed on how to evaluate the derivative at a given point given the equation of the tan line. It reads, functions f, g, and h are twice differentiable functions with g of 2 equals h of 2 equals 4. The line y equals 4 plus 2/3 x minus 2 is tangent to both the graphs of g at x equals 2 and the graphs of h at x equals 2. The A part, you have to find h prime of 2. Alright, so let's go ahead and refresh our memory as to what the derivative at a point means. So recall, if you're asked to find f prime of a, what are you being asked to find? What is another way to express this f prime of a? So let's write Mathgotserved down real quick to guide us. Alright, so remember, if you're looking for the derivative, it's the same thing as finding the slope of the tangent line or the rate of change. In this particular problem, we're looking at the rate of change, the slope of the tangent line scenario. Why? Well, it is because we are given the equation of the tangent line. All right, so this line right here is the tangent line. So derivative is the same thing as the slope of the tan line. If we can find out what the slope of this line is, then we're good to go. Okay, so f prime of a is equal to the slope of the tan line at x equals a, or it's also viewed as the rate of change of f at a. All right, but we're looking at the first representation in this example. Now let's adapt this fact to what we're looking for. So h prime of 2 is basically the slope of the tan line to h at x equals 2. All right, so all we just need to do is identify the equation of the tan line. If we can find the slope of that, then we're good to go. Alrighty, so we already know what the equation of the tan line is, right? So the equation of the tan line to h at x equals 2 is given by y equals 4 plus 2 over 3 times x minus 2. So can we find out what the slope of this line is? You can differentiate, but there's an easier way to do it. So we can use algebra to solve this particular problem. Now, do you remember what form this line is in? This line is in the point slope form, right, with y isolated. So we have the point slope form of the equation of the line is given by y. Y minus y1 equals mx minus x1. So if you get y by itself, is the same thing as y equals y1 plus m x minus x1. Okay, so this function is y equals 4 plus 2/3 x minus 2. So what's the slope of this line right here? The coefficient of x, right? Or what's in front of that quantity, x minus x1. So we can clearly see that our m is 2/3. All right, so that's one way of doing it. Is the quicker way using algebra, or you can just differentiate this right here and then you get 2/3 also. Okay, so h prime of 2 is basically the slope of y, which is 2 over 3. That's the slope of the tangent line. So how was this problem graded on the AP exam? This problem 6A was a one-pointer. So if you can just find h prime of 2, you get 1 point. Alrighty, let's take a look at question 6b. In question 6b, we're being assessed on how to apply the product rule. Alright, so it reads, let a be the function given by a of x equals 3x to the third h of x. Write an expression for a prime of x and find a prime of 2. Alright, so to get us started with this, there are 2 pieces of information that we need, okay? That's not stated here. So in the original question, we're given h of 2. We're given h of 2 equals 4. And then we found h prime of 2 in part A. We just found it. In part A, we found h prime of 2 is equal to 2/3. All right, so these 2 pieces of information are needed to complete this problem. All right, so what formula is going to guide our problem solving process here? The formula that we're going to be using is the product rule. So do you remember what the product rule is? All right, let's go over that real quick. So if you have the product of 2 functions, u times v, product rule just tells you that it's v u prime plus uv prime. All right, that's what the product rule is. So let's apply it to this particular function that we're dealing with. A of x is equal to 3x to the third times h of x. Now, how do we know that this is a product rule problem? Well, you notice a of x is a product of 2 functions, cubic monomial 3x to the third and the function h of x. Okay, so if we're looking for the derivative of this a prime of x, we're going to have to differentiate the product of these 2 functions. Okay, so we need u and v. So let's call 3x to the third 3 times x to the third u, the first function, and then we'll call the second function h of x v. Now, let's apply the product rule here. So if we have u times v prime, that's going to be vu prime. Let's do that first. So it's going to be v is h of x. So v is h of x times u prime, derivative of 3x to the third. All right, vu prime plus uv prime. So plus u is 3x to the third. And then we're going to multiply that by v prime. V is h of x. Okay, now let's go ahead and differentiate. So we're going to have h of x times, now if you apply the power rule to 3x to the third, you power down and mark this down, you have 9x squared, okay, plus, and then this is just 3x to the third times h prime of x. So a prime of x, our first answer is going to be 9x squared times h of x plus 3x to the third h prime of x. And that's the answer to question number 6b, the first part. All right, so this is the derivative. Now let's go ahead and find a prime of 2. A prime of 2 is the slope of a tangent line, or the rate of change at 2. So how do we find a prime of 2 given a prime of x? A prime of 2 just simply means that you evaluate your derivative, a prime of x, at x equals 2, right? Because that's what's substituted in here for x. Let's do it. So we're going to have a prime of 2. We already have a prime of x here, so we'll just take out all the x's and replace it with 2. So 9 times 2 squared times h of 2 plus 3 times 2 to the third times h prime of 2. All right, let's freeze for a second. What just happened? Well, all we just did is we substituted, okay? We plugged in all the x's, we replaced them with 2's. Now, in some parts, we're going to use PEMDAS. In other parts, we use what we're given or what we found. All right, so the first factor here, 9 times 2 squared. Use PEMDAS there, exponent first before you multiply. You have 9 times 18. Sorry. 9 times 4 times h of 2. We were given, this was given, okay? H of 2 is 4 plus, and then PEMDAS here again, 2 to the third is 8, so it's 3 times 8. And then h prime of 2, we've just found that in part A using the slope of the tangent line, and we found that it was 2 over 3. So what does that give us? We have 36 times 4 is 144 plus 24 times 2/3. And then this is 144 plus 3 goes here, 1, 3 goes here, 8 times 2, 16. And your final answer is 160. Okay, so there goes the final answer to question number 6B. Now 6B on the AP exam, how was this graded? This was a 3-pointer. You get 1 point for setting up the product rule. You get another point for applying it correctly and finding a prime of x. And then you get the last point for evaluating the derivative at 2. All right, for a total of 3 points in question number 6B. Alrighty, let's take a look at question number 6C. In question 6C, we're going to be evaluating functions and finding the slope of a tangent line using limits and L'Hopital's rule. Okay, so question 6C reads, the function h satisfies h of x equals the quantity x squared minus 4 over 1 minus f of x to the third for x not equal to 2. It is known that the limit of as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2. Show the work that leads to your answers. All right, it was stated earlier in the question 6 that function h is differentiable. Okay, so what does that tell us? If h of x is differentiable, that automatically means that h of x is continuous at x equals 2. All right, because continuity is a condition for differentiability. If a function is discontinuous at a point, then it's not differentiable there. All right, so this continuity is the key that can help us to solve this problem. All right, so if a function is continuous at a point, what do we know? Well, we know that the double-sided limit is equal to the value of the function. So let's recall that. Recall that if f of x is continuous at a, then the double-sided limit is equal to the value of the function at a. Okay. All right, so this is the verbal representation. Symbolically, what I'm saying here is that the limit as x approaches 2 of, a of the function is going to be equal to f of a. This is a condition for continuity. All right, so we're going to be applying that here. Let's apply this fact to this scenario. Since h of x is continuous, at x equals 2, then we know that the double-sided limit is going to be equal to the value of the function. So the double-sided limit is the limit as x approaches 2 of h of x. This is going to be equal to h of 2. Alrighty. Okay, so we are given that this was a given earlier, that h of 2 is equal to 4. That was given in the original problem. So we're going to be using that here. So we can make the substitution here. So what we're going to do is take h of x, all right, this quotient, this rational function right here, plug it in here, and then use the given and plug it on the here over here. Okay, so this goes on the left hand side, and this one will go on the right hand side. All right, so let's make the substitution. So it's gonna give us, using this equation that results from the continuity of h, is gonna give us the limit as x approaches 2 of whatever h of x is, which is x squared minus 4 divided by 1 minus f of x raised to the third power. So this is equal to h of 2, which is given to us as 4. Okay, so let's go ahead. So remember what we're looking for. We're looking for f of 2's. Okay, so when we make our substitution, you're going to see f of 2 identify itself. So let's make a substitution here. This is a finite limit. All right, so we're going to salide the left side. If we make a substitution, we're going to have 2 squared minus 4 divided by 1 minus f of 2 to the third power equals 4. Okay, so now this becomes an algebra problem. What are we trying to solve for in this algebra problem? Well, we're just trying to get f of 2 isolated. That's the goal. Okay, all right, let's do it. So in the numerator, we have 0. 2 squared minus 4 is 0 over 0 over 1 minus f of 2 raised to the third power. Put this for us, put this over 1, okay? And then we just cross multiply. So when you cross multiply, you're going to end up with 0 equals 4 times 1. Let's write this. So 0 equals 4 times 1 minus f of 2 raised to the third power. Okay, so the goal is to get f of 2 by itself. All right, so that's what we're doing now. It's no longer in the denominator, which is excellent. So to get f of 2 by itself, we just divide by 4, subtract 1, and take the cube root, and we're good to go. All right, so if you divide both sides by 4, both sides of the equation by 4, what do you get? You get 0 equals 1 minus f of 2 raised to the third power. Okay, and then subtract 1 from both sides. If you subtract 1 from both sides, you have negative 1 equals negative f of 2 raised to the third power. Divide both sides by negative 1. You have 1 equals f of 2 to the third power. And then to get f of 2 by itself, you just take the cube root of both sides of your equation. Like that, like that. And then you get f of 2 is equal to 1. All right, so there goes the answer to the first part. All right, and then the second part, we're looking for, what are we looking for? F prime of 2. All right, so it's indicated earlier that, let's see what it was, are we told here? All right, so now we're gonna find f prime of 2. So how can we introduce f prime into this whole situation where we're dealing with limits? How can we do that? So to find f prime of 2, we have the key here, and that is, where is it? L'Hopital's rule. So that's what we're going to be using to solve this problem, okay? All right, so let's recall what L'Hopital's rule is, and then we're gonna apply that to the second part. So what is L'Hopital's rule? It's as follows. So if you're looking for the limit as x approaches a of a rational, let's say f of x over g of x, okay? And both of them are differentiable. functions f of g. In this particular case, we know that they're both differentiable. So this is the same thing as the limit as x approaches a of the derivative of the numerator. Derivative of the numerator over, how do I keep putting a? Derivative of the numerator divided by the derivative of the denominator. Okay? From x over g prime of x. And then, of course, eventually you can then plug in the a's in there, and then you go from there. Okay? All right, so this is L'Hopital's rule, and we're going to apply it to this scenario to figure out what f prime of 2 is. The goal is we're trying to introduce a derivative component into the equation. So take a look at this equation that we had set up right here in the first part. That's going to be our starting point. Okay, so we're going to put this over here. So we have this limit as x approaches 2 of x squared minus 4 over 1 minus f of x raised to the third is equal to 4. All right, we already got that from this part. Okay, now if we apply L'Hopital's rule, to the left-hand side, of course. L'Hopital's rule only applies to limits of quotients, right? Okay, so if we apply L'Hopital's rule to the left side, this entire thing is the same thing as a limit as x approaches 2 of x squared minus 4 prime divided by the denominator 1 times the quantity f of x to the third prime. That is the same thing as 4. The limit doesn't change. Okay? See what L'Hopital's rule says here. All right, so it's the same thing. So what we're going to do now is we're going to go ahead and differentiate, okay? All right, so let's differentiate the numerator and the denominator separately. So when you differentiate the numerator, you have term by term differentiation. It's just going to be 2x. The derivative of 4 is 0, okay? So it's 2x divided by, and then in the denominator, you differentiate 1 is 0, and then here we have the composite function, so we have to use the chain rule, okay? So we're going to have negative derivative of the outer. The outer is u to the third, okay? So if you differentiate that, that'll be 3u squared. So it's going to be 3u squared, but u is the inner function, so it's 3 times f of x squared times the derivative of the inner function f prime of x. Okay, so that's the application of the chain rule because we have a composite function here. So that is equal to 4. All right, so now that we're done differentiating, we're going to evaluate this entire equation and evaluate the entire thing at x equals 2. Okay, because we're trying to look for f. We're trying to look for f prime of 2. Okay, so we already have the f prime component introduced into our equation. So when we plug in 2 there, then we can have exactly what we're looking for. So evaluate the entire equation at x equals 2. So that's going to give us 2 times 2 over negative 3 times f of 2 square times f prime of 2, and this is a constant, it's just 4. All right, so now it's just algebra. Let's get f prime of 2 isolated, okay? We have another unknown here, which is f of 2, but look at the first answer we got. We had f of 2 is 1, so we're going to use that over here. So substitute that in here. So we have 4 over negative 3 times f of 2 square, which is 1 square, times f prime of 2 is equal to 4. All right, so let's simplify this. Let's see what we get here. Make it look pretty. So we have 4 over negative 3 times f prime of 2 equals 4 over 1. Okay, so just cross multiply. And then we have 4 equals negative 12 f prime of 2. And then to get f prime of 2 isolated, you divide both sides by negative 12. Both sides of negative 12, negative 12, and that will give you your final answer. F prime of 2 is equal to negative 1 over 3. Alrighty, so there goes the answer to the second part. Now, how was this problem graded on the AP exam? Well, this is a long problem. As you can see, it's a 4-pointer. So the first one involves setting up this limit using the fact that h of x is continuous, and that enables you to set up the equation that the double-sided limit is equal to the value of the function. So you get 1 point for this. You get another point for completing the first part. F of 2 is equal to 1. And then if you accurately apply L'Hopital's rule right here, you get another point. And then if you finish it off to isolate f prime of 2 as being equal to negative 1/2, that's your final point. Okay, so for problem number 6C, you have a total of 4 points. Alrighty, let's take a look at question number 6D. And in this part, we're going to be using the squeeze theorem and continuity to find out if a function is continuous at a specific x value. Okay, so 6D reads, it is known that g of x is less than or equal to h of x for 1 less than x less than 3. Let k be a function satisfying g of x is less than or equal to k of x less than or equal to h of x for 1 is less than x less than 3. Is k continuous at x equals 2? Justify your answer. All right, before we talk about what the goal is for this particular proof right here, let's talk about, let's review what the squeeze theorem is. Okay, so you have to recall what the squeeze theorem is because we're going to need it to solve this problem. So the squeeze theorem is as follows. So let's say we have a situation where a function g is bounded between two functions. Okay, so if f of x is less than or equal to g of x is less than or equal to h of x, so we have a situation where function g is bounded between f and h, and we know that the limit as x approaches a of the upper bound and lower bound functions f of x is equal to L. So limit as x approaches a of f of x is equal to the limit as x approaches a of h of x. Let's say they're both equal to L. Then what is the conclusion? Based on the squeeze theorem, we arrive at the conclusion. Then this function that's bounded between f and g, its limit at x approaches a is going to be bounded between L and L. So what number is between L and L? It's just L. They're all the same, right? So then the limit as x approaches a of the bounded function g of x is also equal to L. All right? So there goes the squeeze theorem right there. Okay, so in order to show that k is continuous, what do we have to show? All right, so let's go ahead and identify what our objective is here. So the objective is as follows. In order to show that k is continuous at x equals 2, we just simply have to show that the double-sided limit at x equals 2 is equal to the value of the function. Okay, so in order to show this, all we just have to do is we must show that the double-sided limit of k of x is the same thing as the value of the function k of 2. That's all you have to show. Okay? All right, so let's go ahead and do it. So in the original part of the problem, if we scroll up, it stated that the functions g and h are differentiable. Okay? So what's the condition for differentiability? We went over this in the previous part. Let's go over that again. Since g of x and h of x are differentiable, it follows that what? It follows that they are continuous. The condition for differentiability is continuity. All right? So since they're continuous, that basically means that their double-sided limit as x equals 2 is going to be equal to the value of the function, okay? So this is going to be equal to g of 2, and we're given that this is 4. And the same applies to h also. Limit as x approaches 2 of h of x is going to be the same thing as h of 2, which is equal to 4. All right, so this is based on the fact that these two functions are continuous. All right, what do we know? We're also given that we know that g of x is less than or equal to k of x is less than or equal to h of x, all right, for the specified interval. So this is the first condition of the Squeeze theorem, is that you have k of x bounded. So let's go back and look at the Squeeze theorem. So if you go back and look at the Squeeze theorem, the first condition is, what if you have a bounded function, okay? You have a bounded function between f and g. And then the second condition is that the upper and lower bound functions, boundary functions f and h, are both, they have the same limit. So in this case, that's also the case here. So we know that k of x is bounded between g of x and h of x. And we also know that, based on this fact right here, that the limit as x approaches 2 of g of x is equal to the limit as x approaches 2 of h of x. They are both equal to 4. Okay? So what is the conclusion that we can make? By the Squeeze theorem, we can make the conclusion that, so this too implies that the limit as x approaches 2 of k of x must also be equal to 4. All right? So now we've shown that the limit, the double-sided limit, is equal to 4. Okay? So let's go back to our objective. So the objective is to show that the limit, the double-sided limit, is equal to the value of the function. So we've been able to show that this side, the left side, is equal to 4. Now can we show that this side, k of 2, is also equal to 4? Can we show that? Well, let's go ahead and do that. That's not too complicated to show. We know what g of 2 and h of 2 are, right? So from this inequality right here, g of x is less than or equal to k of x is less than or equal to h of x. If we evaluate this inequality at 2, x equals 2, what do we have? We have g of 2 is less than or equal to k of 2 is less than or equal to h of 2. But we know that g of 2 and h of 2 are both 4, right? So 4 is less than or equal to k of 2 as less than or equal to 4. So what number is between 4 and 4? It has to be 4. So this inequality automatically follows that k of 2 is equal to 4. All right? So the right-hand side of the equation is also 4. So now we know for a certainty that k is continuous at x equals 2 simply because How do we know? Because the double-sided limit as x approaches 2 of k of x is equal to the value of the function and is equal to 4. Alrighty, so if you can show this equation holds, then you have been able to establish that the function is continuous at that particular point. Okay, so on the AP exam, this was a one-pointer. If you state the show that it's continuous and you provide the justification why it's continuous, then you earn your 1 point. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming AP Calc exam, do give us a thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel. We upload tons of math tutorials to our page on a regular basis. And if you have any questions or comments about what we covered in this tutorial or any calc questions in general, just put it in the comment section below and we'll be more than glad to support you. There are tons of support resources, including our epic formula sheet and all the things you need to know to pass the AP exam at our website, mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.